Okay, hello everyone. In this video, we are going to quickly run through first law of thermodynamics. Okay, now, first off, we define the first law of thermodynamics. It says the heat is a form of energy, and that energy cannot be created or destroyed, but can be transformed from one form to another. Okay, based on this, then the total energy in an isolated system is constant and conserved. Okay, the total energy in isolated system is constant and conserved. Then we see that energy is transferred to and fro from a system in form of heat and work. Now, this third statement is not a law, is not the law, but you should know that heat can be transferred from one form to the another. The way it is being transferred is in form of heat. The way energy is transferred between two bodies is either in form of heat and work. Okay, so this is the mathematical expression for the first law of thermodynamics, that delta U is equal to Q minus delta W. Okay, Q minus W, sorry. Delta U there is the change in internal energy of the system. Q is the heat added to the system, and W is the work done by the system. Okay, in another video we are going to look at the real definitions for internal energy, but for now just know internal energy is the sum of the kinetic and the potential energies of the particles that makes up a system. Okay, that is the internal energy. And the kinetic energy is due to the motion of the particles. According to kinetic theory of matter, particles are constantly in motion, and the potential energy is due to the interaction between the particles and also the chemical bondings, and all that. But for an ideal system, you can say that the potential energy is equal to potential energy is equal to zero in an ideal system, because for ideal gases, the forces of attraction are negligible. But for the purpose of this video, we are going to concentrate on this formula. Okay, so now we look at this question. It says a system undergoes a process where 500 joules of heat is added to it, and it performs 300 joules of work on the surrounding. Calculate the change in internal energy of the system. Okay, so you'll notice that the system undergoes 500 joules of heat. So we can come here and say added to it. So Q, the amount of heat added to the system, is 500 joules. Okay, and it performs 300 joules on work on the surrounding. Now kindly note that the work on the surrounding also means the work by the system, because when the system does work, it does work, it is doing the work on the surrounding. So we can say here that the work W equal to 300 joules. So we are asked to calculate the energy, the change in the internal energy of the system, based on a formula. We know delta U is Q minus W, so that will give us 500 minus 300, and our answer is 200 joules. Okay, so that is how that is. Now, but we want to note a sign convention. Okay, first of all, if heat is added to the system, Q is positive. Okay, if heat is removed from the system, Q is negative. The value of Q will be negative. So that means for the first statement, heat being added to the system, that's an endothermic reaction. For the second statement, heat being removed from the system, that's exothermic. Q is negative. Now, but if work is done by the system, W is positive. Okay, W is positive if work is done by the system. But if work is done on the system, that's a mistake. This should be on. the system, then W is negative. So work done on the system means the work is done by the surrounding. I will be doing a video on system surroundings and all that. Okay, so let's see a question here. It says in a thermodynamic process, okay, that when the pressure of a fixed mass of gas is changed, 30 joules of heat is evolved. Evolved there means heat is released. So that means our Q here is equal to 30 joules. And 10 joules of work is done on it. So sorry, this is minus negative 30. And 10 joules of work is done on it. That would be negative 10 joules, okay? So we are asked to find the final internal energy. Now our internal energy, delta Q, like we know, is Q, delta U is Q minus W. So that would be negative 30, then minus negative 10. Okay, so that will now be negative 30 plus 10, and that is negative 20 joules will be the answer to our question. Okay, so thank you very much. Watch out for the next video.